All right, initially this particle is at x equals 1, so it starts here at x equals 1, and it's got a velocity of negative root 2 meters per second, so it's actually going to the left. The force is 6x, so force, remember, is mass times acceleration. I don't know why I put that there, let me go again. So the force, which is mass times acceleration, they're telling us is equal to 6x squared newtons. Mass is 2, so you can see that acceleration is going to be 3x squared, and we're going to start there. So if we want the velocity squared as a function of x, so we're going to use d by dx of half v squared, and that will mean half v squared is equal to 3 integral x squared dx. Here. So what do we get there? We get 3x cubed on 3, so actually that's going to cancel, plus c. And what can we put in to start? Well, we do know the velocity is negative root 2, so if I put negative root 2 in there, so I've got a half negative root 2 squared, x is 1, so that's going to be 1 plus c. So when we do that, you can see negative squared is positive, root 2 squared is 2, 2 times a half is 1. So you can see there that c is going to be 0. So if we go back, we're going to get half v squared is equal to x cubed plus 0. So I'll just leave it like that, or in our case, so we're going to get v squared equals 2x cubed. So that's the equation we were looking for there. All right, so then find the displacement time function and briefly describe its motion. All right, so remember displacement time, we want x and t, so we can use velocity as dx to t here. Really, which velocity equation to use, because we know here that v would be plus or minus the square root of 2x cubed here. So what to do about that? Well, one thing you can do is have a look at the conditions. So velocity has to equal a negative root 2 when the x is 1. So therefore, because of these conditions here, we're looking at the velocity being negative root 2 x to the, I'm going to put 3 on 2 here. Yeah, so we're going to use that one. So let's go for velocity is dx to t. We're going to have to tip everything upside down because where the x's are. So when I tip it upside down, I'm going to get t equals, tipping this upside down, negative 1 on root 2. The integral is tipping this upside down, will be negative 3 on 2 to that power with respect to x. When we do that, so we know we've got the negative 1 on root 2 here, negative 1.5, if we add 1 we get negative 1/2, so this is going to be x to the, I'm going to put it down here, x to the negative 1/2 will be like that, and we're dividing by that negative 1/2, so we need to change that to a plus and that to a 2. It's indefinite integral, so I'll put plus 3. Alright, so 2 on root 2, remember, is the same as if we times by root 2 on root 2, we just get a root 2. So I'm going to go back up here, sorry for this working. So I've got this root 2, and I'll put it all together on a root x plus c here. So what do we know? We know initially the x is 1, so initially x is 1 is what we know. So let's put that in. So we get 0 is root 2 plus c. So you can see c is going to be negative root 2. So let's put that in. So t is going to be, I'm going to go like this, minus root 2 there. All right, so we want x, we want the displacement time. So we want x to be the subject here of the equation. So what I might do is put x by itself. So I'm going to actually put root 2 on x, leave it by itself, and put the the root 2 with the t there. And then square both sides. So we're going to get a 2 on x here. We're going to get a t squared, a 2 root 2t, and a 2 here. Actually, I might just leave that as a t plus root 2 all squared. That's easier, looks nicer. And then we're going to tip that upside down and times by the 2 over here. So the 2 is going to go at the top here, and we're going to have t plus root 2 all squared here. All right, so that's the displacement time equation there. And you can see we started from, if I just go back to our picture up here, we started from x equals 1 and we were going left. So if I just do that here, we started from 1, here's the particle, and it's going left. And you can see as time goes to infinity, as it gets bigger and bigger and bigger, what we're doing is we're saying 2 divided something really, really big. So you can see x is going to go towards 0. So it's going towards 0, but it's, there's a force this way. So it's getting slower and slower and slower and slower. It's never reaching 0. It's just slowing down.